Welcome students to our last lesson of the semester, the July 8th lesson on geometric sequence. That's all we're going to focus on today. So let's get started. All right. So our first part is we're going to learn how to write a recursive and explicit formula. All right. So remember, geometric sequence means that it's being multiplied. Even though the number is getting smaller, you're multiplying by like some sort of number that's less than 1, between 0 and 1. Something bigger, obviously you're multiplying by something that's bigger than 1. All right, so let's look at this one here. As you can see, it's 81, 27, 9, and 3. Looks like it's being divided by 3. In this case, it's being multiplied by 1/3. So it means the same thing. Divide by 3, multiply by 1/3. Okay, so this the multiplier, they call it the letter R. It's multiplied by 1/3. All right. So let's look at the number before. So if you multiply it by 3, that will give you a number that you were to divide by 3, gives you 81, which happens to be 243. And remember, this is our n is equal to 0. That's before. This is our before our first number, okay? We're gonna need all that later, all right? So let's do explicit first. Okay, so let me move this one over quickly. And I'm just trying to ignore this last part right here, okay? All right, so anyway, again, our first number is 81, our multiplier is 1/3, and our beginning, the before number is 243. All right, then all you do now is just write down your equation. You're already done. So t of n, this equation here. Okay, again, for the explicit one, you always want to use this one here. That's the number that you multiplied before. So you want to, okay, so before was 243. You can multiply it by 1/3. That will give you the 81. So where does the formula come from? This just gives you 81. Just remember, guys, it's going from multiply by 1/3 and then 1/6 and so on. So what you need to do is just the exponent becomes an n like that. And that's all you do. And that is it. Again, the before number, your multiplier, and then an n. All right. Now for recursive, it sounds tricky, but it's actually a bit easier. All right. Okay. So this is our recursive number right here. Okay. So what does that equal to? This means that what's going to happen on the next number. So we want to focus on the next number, which is 27. All right. So all you have to do is just go, okay. So first thing, our multiply is 1/3. Sorry. Okay. So all you do go, okay, so our next number, so t, what's a recursive, meaning what is going to happen to our next number, whether it's, if it's going to be after 81, after 27, after 9, after 3, or so on, what's going to happen to our next number, all right? All right, so anyway, so let's go ahead and, so that's our formula right there, that's happened to our next number, and it's actually fairly easy, okay? You just have to write down what's going to be our next one, and our first one is 81, all right? So this is basically t of n multiplied by 1/3. All right, and that's all you have to do. Okay, and that's it. If there's any question, well, we'll move on to our next one. If you have any questions, let me know. Okay. All right, so let's move on to our next one here. All right. So this one is, oops, I'll put 81 here, my bad. All right, so let's go ahead and do the explicit one, and we'll move on from there, okay? All right, so anyway, as you can see, it's going up by multiplying by 3, okay? So our multiplier is 3, and our beginning number, it's gonna be before 3, so you have to go, okay, it's getting bigger, so this one you divide by 3, so it's 5/3, because 5/3 times 3 will give you the 5, you see? So this is 5/3. All right, so our equations is already done. Now you just write down, okay, t of n, the number before, multiplied by our multiplier, which is 3, and the first or the second number, okay? And our recursive, again, just focus on the multiplier, which is 3, okay? And then again, just write this one down, t of n plus 1 is equal to whatever our first one is, t of n, whatever that number is that we're looking for, the number that we're looking for after, okay? So the after number, and then just multiply by 3. like that. All right. All right, let's move on to the next one. I want to find a 20th term, okay, for the next one. Okay, so the 20th term. Not the 19, not the whatever, but they'll give you something that's a hint. For example, they're saying that, hey, the 19th term, so the one before this one is 110. So the multiplier is multiplying, so it's getting smaller. All right, so for this one here, you have to understand that since it's gonna get, this is actually, the next number is gonna be smaller, okay? So what you have to do is just go, okay, so the t of 20, it's just, again, it's gonna be smaller, can you multiply? So this is multiplied by half, so just 55, like that. All right, now, look at this one here, okay? So this one, they want the number after. Okay, so after 20th term, okay, so then this, again, don't worry about this one. This is a separate problem, all right? So they want to know, go, wait a minute. So the number after is 110, so the number before, since it's getting smaller, it has to be bigger than this number, okay? So you go, okay, since it's bigger than this number, so you just multiply that by 2. So our t of the 20th term has to be 220 because you're going by half, because our next number would be half of this, that's why it'd be 110. All right, so let's look at number 5 quickly. All right, so number 5 says that the number before the 20th is 5. Okay, so the number after the 20th, it's going to be bigger. Okay, so you just go, okay, look, it's going from 5, so you know you multiply that by 6. Okay, so the t, again, it has to be bigger than 5 because your multiplier is bigger, so your 20th number has to be bigger. Okay, so all right, let's go ahead and do bigger, so that's 30. And there you go. Okay, and then finally this one here, the 20th term, and this one you just have to go, again, it's being smaller, so then your t of 20 is just 5, and then again, it has to be bigger, so that's why it's like that. All right, give me a second here. All right, so 6. Okay, for our very last problem. Okay, let's see a look real fast. All right. So we have to list the first 5 terms. Okay. So for this one right here, let's take a look real fast. Okay. So our first one, okay, is to the 1 power, and then after you can see here the multiply is 3. Okay. So let's just go ahead and put down the first number. So -3 times 3 to the 1. So that gives you -9, and you know you're multiplying by 3. Okay, so let's just go and multiply that by 3. So times 3 is 27, -27, times 3, I might need a calculator for this one here. All right, so you multiply this by 3, so 27 times 3, I know it's a negative, so -81 times 3, that gives you 243. And the next one, that's 1, 2, 3, 4, next one times 3, and it'll be -729. All right. All right, for our next one, again, this one's a little bit trickier, but anyway, let's go ahead and put a 1 in there. So 6 times -1/2, so 1 minus 1. Okay, that would be our first number. This one's a little bit trickier. So 1 minus 1 is 0. So that would be 6 times 0, so that's 1, so that'd be 6. Okay, and our multiplier is -1/2. So this one, again, is actually really, really tricky for this one. But anyway, so our first number is 6. You have to multiply it by -1/2 since our multiplier is -1/2. So that gives you -3. That'll be +3/2, -3/4, and finally +3/8. All right. That one is really, really tricky. All right. Now, what happened if it's a recursive one? For a recursive one, all you have to do is just find out, oh, okay, this is our first number, and that's our multiplier. So that's actually really, really easy. All right, so our first number is 100, and you're dividing by 2, so 50, 25, 25/2, 25/4. And that's all you have to do right there, okay? So finally, our last one. Okay, our first number is 1/3. As you can see, it tells you right there that's 1/3. See, 1/3. So what you do now, oh, your multiplier happens to be 3. So I'll multiply by 3, it gives you 1. Okay, give me a second here. So you multiply by 3 again, and it's gonna give you 3 927. All right, I think that's about it. Thank you, and have a great day.